Okay, students, welcome back. I hope you didn't find the density questions too difficult. The next assignment, we're going to have a look at something called the Cartesian diver. Obviously, if we were in the lesson, then I would show you a Cartesian diver, but we're not. But there are a couple of videos that I would like you to watch. One of them is this young guy here pretending to do a magic trick. You can actually set this up yourself if you've got any ketchup packets. You know those packets that you get, it doesn't necessarily have to be a ketchup packet, it could be any sauce, but when you order a pizza you get loads of packets that you never really use. Well, you can actually make one yourself, a Cartesian diver, from those packets, but it needs to float. So if you put them in water, excuse the pun with the current conditions, but if you do put them in the water and it floats, then you can set up one of these. What I'd like you to do is watch this video first of this guy doing this. It's about 5 minutes long. Obviously I'm not going to watch that in our video, and then you can watch the second video as well, which is by a guy called Spangler, about how it works, which is a pretty cool video as well, and that one's about 3 minutes, let's say. So watch those two first. The links for those are actually on our Edmodo site. I put them on there earlier today, so if you scroll down you should be able to see those things there. But what I'm going to do, what I'd like you to do now, I'm going to pause now, and I'd like you to pause this video and go and watch those two videos on this link. Okay, so now you've watched the videos, I'm actually going to teach you about what's going on, and it's all to do with forces, obviously. And if I use this table here, on this table we have got, if I just get my mouse, you can see we've got here, let me get my pen, we've got 4 situations. Really, this one should be 2, this one should be 3, this one should be 4. 4 situations, and we are going to draw the force diagrams for those 4 situations. The first one is a Cartesian diver floating stationary at the surface. So I'm going to represent my Cartesian diver using a